Hi everyone, welcome back to this video series for firewall introduction to firewalls. Identifying the risks to the resources. You must identify all risks facing the resources. Identifying risks helps you determine what types of protection you need to implement in order to reduce those risks. When considering potential risks, you sometimes have to think creatively. Some risks have a higher probability assigned than others. Some of the generic risks that may exist for a resource include unauthorized access to the resources. The resource may require limited access. If an attacker can connect to the resource over the internet or physically access the resource, the security of the resource may be possibly compromised. Unauthorized disclosure of information. After a resource is accessed, even more harm can be done if the information is publicized. The disclosure of sensitive data may lead to the company's image being tarnished or potential loss of business for the company. Unavailability of the resource due to denial of service attacks. Denial of service attacks prevent access to the resource by attacking either the resource itself or the hardware that provides access to the resource, determining the probability associated with the risk. A project team needs to predict the probability of the threat associated with each risk occurring, developing a security strategy to address a threat that's unlikely to occur and that would cause only minor damage is senseless. Your time and money are better spent in providing security against threats that are more likely to take place. After you have determined the probabilities, you can then prioritize the resources that you must secure. In general, you can determine the costs that you face if the resources are compromised by multiplying the cost of the resource or the probability of the damage occurring. Obviously, you want to prevent the highest cost risk from occurring. Mitigating the risk. The actions that you take to reduce risk can range from placing the resource in a physically secure location to implementing a secure area of your network that limits what protocols are allowed to connect to the resource from the internet. The definition of the mitigation techniques would serve as the guidelines for the firewall rules. The security policy defines what actions the company sees as appropriate to mitigate specific risks. Chapter 7. Establishing rules for simple protocols. This chapter examines the firewall rules that allow both inbound and outbound access for commonly used protocols. The network shown in figure 7.1 serves as a sample network for our discussion. Although these rules may seem monotonous, they are the essence of firewall configuration. After you get the hang of configuring firewall rules, you can easily extend the scenario and create more sophisticated rules to meet your security requirements for new protocols. These rules can be simple or complex, as the next sections make clear. This chapter looks at the firewall rules required to allow the following protocols to pass through the firewall. Web access. Many organizations host their own websites and require a firewall to limit access to the web server and only those who use approved protocols. In addition, internal users of the organization require access to web servers on the internet. Name resolution. When you access the internet, you enter the fully qualified domain name FQDN of an internet site in your browser. For example, when you enter www.dummies.com, name resolution resolves the FQDN to the IP address 208.205.179.139. Most organizations require their firewall to allow both inbound and outbound name resolution. File copy protocols. File copy protocols allow the transmission of large data files between organizations. Firewalls must be configured to allow both inbound and outbound flows. Outbound traffic flows, messaging, chatting, and conferencing. With increased bandwidth, most users are utilizing internet messaging, chatting, and conference services to increase productivity and accessibility to the other users on the internet. A firewall must be configured to allow outbound access to these services. Thin client solutions allow terminals and older client operating systems to connect to a central server running terminal service sessions. All processing takes place at the back-end terminal server, and only screen and input information is sent between the client and the server. Firewalls must be configured to allow both forms of access. Other business protocols. Organizations may require access to new services or want to allow users to ping hosts on the internet while blocking ping access to internal resources. This chapter looks at configuring inbound and outbound firewall rules for these services. Some default rules. Before we delve into tables and more tables of firewall rules, we need to describe some of the more common default firewall rules that are implemented on today's firewalls. Default strategies. A firewall will deploy either a deny all or a permit all strategy. What this refers to is how the firewall deals with a packet that doesn't match any of the defined rules at the firewall. If a deny all strategy is implemented at the firewall, a packet that doesn't match any of the defined firewall rules is prevented from traversing the firewall. Likewise, if a permit all strategy is implemented at the firewall, a packet that doesn't match any of the defined firewall rules is allowed to pass through the firewall. For most firewall products, you don't have to create a deny all or permit all firewall rule. Instead, the firewall product either allows you to define the strategy or it implements one of two strategies as its default behavior. Inbound versus outbound rules. When you define firewall rules, direction is an important characteristic. The traffic that you want to allow outbound from your network may not be the traffic that you want to allow inbound. For example, although your organization may want to allow users to connect to any website from the internal network, you may find it in your best interest to limit inbound connections only to the organization's public web server. Block obvious IP address spoofing. This one is easy. When IP addresses are assigned to your network, you will know the IP addressing scheme used on the internal network. A firewall can be configured to block packets if they arrive at the external interface of the firewall but have an internal IP address as their source address. Likewise, if the source address is a private network address as defined in RFC 1918, the firewall can block these obvious IP address spoofing attacks, allowing web access. Web access is the most common form of traffic that passes through an organization's firewall. The two most common applications used to access the web are Microsoft Internet Explorer and Netscape Navigator. From a firewall's perspective, it doesn't matter which browser you use because both browsers utilize either HTTP or secure HTTPS protocols. So you can see here securing data with SSL. So one, the web client attempts to connect to the web server by using the URL that starts with HTTPS, representing HTTP protected by SSL encryption. 2. The web server sends its certificate to the web client. The web server's public key is contained in the certificate as an attribute of the certificate. Only the public key is transmitted on the network. The private key is never transmitted, protecting the private key from interception. 6. The web server decrypts the pre-master secret key by using the web server's private key. The pre-master a secret key is used to derive the session key at the web server by implementing the same algorithm implemented at the web client. 3. The web client and the web server enter into negotiation to determine the strongest level of encryption that is supported or required by the web server. 4. The web client generates a pre-master secret key of the length negotiated between the client and the web server. The web client uses a designated algorithm to derive the session key. This session key is used only for the existing session and is never reused. The client computer then encrypts the pre-master secret key by using the web server's public key and transmits the encrypted key to the web server. All the data transmitted between the web client and the web server for the current session is encrypted by using the derived session key. Configuring inbound firewall rules. Inbound rules are required only when you are hosting a web server that is accessible on the internet. The firewall rules ensure that access to the web server is limited to only HTTP or HTTPS connections. Table 7.1 shows the firewall rules that are required to provide access to the internal web server located at IP address 172.16.1.200 from any client on the internet. The table assumes that the firewall uses a deny all except those listed methodology, which means that if a firewall receives traffic for a protocol that isn't in the list of firewall rules, the packet is dropped at the firewall. So you can see here table 7.1 firewall rules to access the internal web server: HTTP, HTTPS, TCP, TCP, any, 172.162.168 allow, 172.16.1.200, 443 allow. Configuring outbound firewall rules. In addition to inbound web access, chances are good that the users of your network want to access web resources on the internet. Table 7.2 shows the firewall rules that are required at the firewall to allow internal network users on the 172.16.1.0/24 network to access any web server on the internet by using HTTP or HTTPS. So table 7.2, firewall rules to access internet-based web servers. Protocol: HTTP, HTTPS, TCP, TCP 172.16.1.0/24, any, 80 allow, TCP 172.16.1.0/24, any, 443 allow. Providing name resolution to the internet-based clients. When you register a name for use on the internet, you are required to provide the IP address of at least 2 DNS servers that are authoritative for the zone on the internet. By authoritative, we don't mean that the DNS servers take charge of the zone, but that these servers always have the most up-to-date information about the zone, and that all name resolution requests in the zone are directed to these DNS servers. When the authoritative DNS server is located behind a firewall, the firewall must be configured to allow DNS connections to the DNS server from any host on the internet. If you exclude any host from connecting to your DNS servers, it will be unable to resolve hosts containing your domain name to IP address, which is another way of saying that it will prevent others from connecting to your internet resources. Table 7.3 shows the firewall rules that are required to allow access to the DNS server located at IP address 172.16.1.206 on the private network. DNS, UDP, TCP, any, 172.16.1.206.53 allow, 172.16.1.206.53 allow. Providing internet name resolution to providing internet name resolution to internal clients. Your firewall has to allow internet-based clients to query your DNS server, and you must provide a way for your internal network users to resolve FQDNs on the internet or face their wrath. If the company has internal DNS services, the internal clients will send their internal DNS queries to the internal DNS server. The internal DNS server can use one of two strategies to resolve FQDNs on the internet. Use root hints. The internal DNS server will find the authoritative DNS server for the FQDN by querying DNS root servers. Forward DNS queries to an internet service provider, ISP. The internal DNS server will forward all unresolved DNS queries to the ISP's DNS server for resolution. Configuring DNS firewall rules when using root hints. When a DNS server is configured to use root hints, it queries one of the DNS root servers to determine which DNS server it should query to resolve the DNS query. See Figure 7.2. Specifically, the DNS server will query the DNS root server that's responsible for the top-level domain queried, such as .com DNS root server. The DNS root server will return a referral to a DNS server that is authoritative to your DNS query. The internal DNS server will then query the DNS server included in the referral. This process will repeat until either the DNS information that the servers are querying is found cached at the queried DNS server. They are referred to DNS server that is authoritative for the DNS zone where the DNS resource record is stored, or a response that the DNS information is not available or does not exist is returned. When root hints are used for DNS resolution, the firewall must be configured to allow the internal DNS server 172.161.206 to send DNS queries to any DNS server on the internet, as shown in Figure 7.2. Due to the uncertainty of which DNS servers the internal DNS server must contact, firewall rules must be established that allow the internal DNS server to query any DNS server on the internet using DNS protocols, as shown in Figure 7.4. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.